And here's section 2. We're starting up. There will be a section 2 quiz at the end. It's going to be a week before spring break. So here we are at week 1, week 2, week 3, and then we'll have a quiz here on the 5th, and then we go away for a week, and then the week after we start up section 3. So there are some like remaining things to dig into. There's like how are pickups happening, like tokens, how are the enemies moving with their patrol points. So I might cover that stuff, but for right now, I did pull these tile map stuff down from section 1 into section 2. And level design is interesting. It's difficult, and there's a whole tool set dealing with it. If it's and usually in 3D, you use these like kit bashing, like there's all these 3D models to build, say, a dungeon. There's all these like columns and walls and anything else that would build up rooms and decorate them. And for 2D, we have this idea of tile maps. So tile maps, these little pixels, these little, not pixels, but a square chunk of your level, and you can like select what type of tile you want to paint onto it. So anyway, here in the Unity manual, here you have tile maps, and there's a lot of areas to cover with it. This is kind of, I don't mess around with it so much, so this is kind of be interesting for me as well. I'm usually mostly in 3D, but here's the tile map renderer. This is what the component object looks like on the game object, and I wanted you to kind of read through the documentation. And here's the workflow, which happens to be this part of documentation. So creating tile maps, creating tiles, and creating a tile palette. And so it looks like first you have to define a tile map, and then you can fill it up with tiles. So it looks like, yeah, it's pretty straightforward. And then it looks like there's a whole importing and prepping of sprites to act as your tile assets. And yeah, you have to set up like your resolution, like your pixels per unit. So each unit, so each little grid square in Unity is meter by a meter. In the 3D world, this is, you definitely have to adhere to it, especially with physics. 2D, I guess you should, like for example, if you're designing human characters, like 2 meters tall would be like 6 feet, and so maybe this like 2 units high by 1 unit width. It is like the space you have to use for like a human character. But what they're talking about is like how many pixels you want to fill up for like one size of unit. So it looks like we have some powers of 2 situation. So the imported sprites, I have to check my set. This doesn't like it, but yeah, 64 by 64, 128 by 128, 32 by 32 are some standard sizes. And then it looks like we have to set up our tile assets into this palette, like a painter tool. And then you select which tile you're going to start painting. And it looks like you can kind of paint right onto the grid. So let's take a look. So I'm going to close enemies. I'm going to close tokens. The zones are the death zones. So I think we go into grid. And foreground, level, background. Background is probably, looks like background is a tile map too. So foreground, we have tile map and tile map render. It looks like we have the map and the render together. Level, we have tile map render, and then we have a collider, because it looks like this is where the character jumps on. The background, there's no collider, but it's its own tile map. All right, so I guess it's these little kind of just create squares. In the far background is also a tile map. And they have this like parallaxer. I was kind of talking about this in section 1, how things, the background like moves slowly, then the foreground gives that feeling of depth, like you're in a real world. It looks like for each of these, when you click on them, you have the open tile palette. And then, okay, we have our 4 different palettes. Default brush. So, okay, looks like you can select an existing part of the grid. And then you have grid selection. Looks like you have to have both these windows open at the same time. You can delete it, move it, rotate it, scale, transform it. So move, paint, the fill box, erase. I'm just going to do a few little actions. I'm going to try deleting. Okay, that's straightforward. I'm going to undo that. Try move. Looks like you need a snapping tool. Usually with tile systems, I think you want to move snap. Is it like X? Hold on, I'm just looking up snap move in Unity. Turn on grid snapping. This snap tool. Oh, this is a part of. Okay, this is a part of another tool. Never mind. Oh, well, if anyone finds snapping, let me know. Anyway, so I'm gonna go back to select. And I'm just gonna see if I can find how to swap out a different tile asset. Must be a way, like when you paint and add, you probably have to rebake. You see how the collider kind of sits on top of everything? There must be a way to rebake the collider. Take a quick look back in documentation. So creating the tile map. Yeah, you can create different ones. We're not doing hexadecimal or anything. Yeah, that's fine. Creating the tiles. palette. Okay, so you're opening up the texture, looking at the sprites. Looks like you can drag them into the tile palette. Using assets. Okay. So it's like one tile, so this is the tile ground. Nope. Let me spend some time with this for Friday. Let me do enemies and tokens, and then I'll do tiles on Friday. That's one part I gotta catch up with tiles on. All right, so we were talking about you're kind of talking about the enemies. Let me just quickly talk about the patrol paths and how these are working. And so if you are interested in editing these enemies or duplicating them, so first you could select one to see what its behavior is. So we have the enemy. It's a prefab because there's like a lot of parts of it. So you don't want to like recreate this all the time. So if you select it, just so that it was a complicated game object, and they ended up bringing it down to the project and saving it out, so it's easy to build up their scene with. We have the renderer and the animator, and I kind of talked about how the animator on the player anyway switches out the different sprites, and so it's controlling like there's different states in here, but death and jumping and running and stuff. So we have a rigid body for moving it, a capsule collider, so you need to know for hitting it. If you edit it, it looks like that. And the animation controller, enemy controller, and then we added some health onto it. So the enemy controller here, you see that you can optionally add a path to it. Like this one doesn't have a path on it. So if you look at the enemy controller, okay. So that was one part of the enemy controller that we're kind of familiar with, is that we did look at the on collision enter 2D. And this is handling the collision between a player and an enemy, or any collisions really with the enemy. It could be the death traps, or even like the collider on the tile map. But here we're just checking if we're hitting the player and we're damaging it. But if you notice that it does have a property exposed for a patrol path object. And it looks like on awake, it's connecting with its animation controller, collider 2D, audio, sprite render, and then it has an update method. So this is called every frame, fraction of a second. And it says if the path is not null, we're going to do some stuff. Otherwise, do nothing. So in this case, the enemy that's right by us doesn't have a patrol path, so he's just going to sit idle and plays idle animation. And if I remember correctly, it was just kind of that slight bouncing up and down. Yeah, it just looks like that. And then if we look at an enemy, this is what a patrolling enemy looks like. This is it's moving left to right to left to back again. So this one has a patrol path on it. So if we come over here and look at this one, this enemy has all the same parts. It's the same prefab. It's just down here. It does have a path connected to it. So here we could open up our patrol paths and click on this one. And here, a patrol path object, game object just has a transform, and it has its patrol path component object. object here. So it looks like there's a publicly exposed property of a start position, end position. These are vector 2s. They have an x and a y, 2 floats exposed. So if I click on patrol path, this is the script that's making that component object. So it is a partial class. Again, this is an advanced topic. We're not gonna just know that like some of the class is written in like another file, and I'm gonna ignore that. So hopefully we don't need to like hunt around and figure out what the other file is. But that's what a partial class means. And so here we have our public property, or vector 2, or 2 of them, start position, end position. They're just defined on the same line. It looks like they're just not set to anything, defaulting to null or whatever. It looks like out here in the inspector, you set the x and the y positions. So next, a public object of mover is created, and so this must be over in like its other file of its other partial. This is so interesting. Well, let me just open mover. Okay. So here's the other part of the partial class, patrol path, and notice the file is patrolpath.mover.cs. Advanced, don't worry about it. Just know that it defines another class called mover. Again, it's overkill. He's like writing a method right here that's run, and it's creating this new mover object. And you're just passing in a reference to this script and to the speed, which is set to 1, which is just okay. So, but ultimately, we had an object here called mover. And mover receives the patrol path file. Yep. So that's the path. The duration, it's going to read in that end position, start position coming in from this file, which I just showed you in the inspector. So it's going to take a vector 2 minus a vector 2, and it's going to get the magnitude of that. So what that's like saying is get the difference of the x and the y's, and it's going to create a new vector 2. And let me just so vector subtraction. So basically it's like saying, hey, if I have say if I'm patrolling between 2 points, and we're just trying to find the actual like the distance between the two. So you saw it was like the 2 points were this and this, which y's were zeroed out. So that kind of makes it a little easier. Just looks at the difference in the x's. But if there were some difference in the y's too, it would take those 2 points, and then when you subtract the two values, you get like a direction. It's just like another vector. It's like what's the difference between the two? So in this case, the difference between these two is you'll get an x difference of like 5, like 5.5, because this is positive 4 and negative 1. So the difference between them is like 5.5, and the difference between them is 0. So you'll get a new, basically it's like how big of a difference is it between the two of them. And when you take the magnitude, I'm just showing you a little bit about this, because if you like become more into game programming, you're going to have to get exposed to these concepts a lot more, and you just have to get used to them. But the magnitude, basically, this might be the best one, saying that like, hey, I have a vector 2. There's a bit of an x difference. There's a bit of a y difference. That's why like it's kind of at an angle. It's like saying it's like move a lot to the right, move a little up, right? And this is a vector 2. It's got x and y information, and that's why it's like a direction. We're going to move x and y. We're moving along a direction. But what if we just want to know the strength of it, the magnitude of it? Like, forget the direction. Just give me one number. Like, how big is this vector? How big of a line? How big of a distance is it? And that's what the magnitude is. And so basically it's saying, like, hey, find me the difference between these two positions. Like, how big of a distance does it have to go over two-dimensional space, x and y, and then just give me one number. Give me how much distance, how many miles, how many feet, whatever do you have to go. And then we're going to divide it by the amount of speed. So basically it's like distance divided by speed is how long does your journey take. So if you have to drive 60 miles and you're going 60 miles an hour, it's going to take you 1 hour. So anyway, and then start time is the current time that we're running. So time.time is just like however long the game has been running, seconds from the start. Just tell me the amount of seconds. And then we have getting the position of the mover. All right, I'll get into that in a second, but we're getting a little obtuse. And hold on, give me back to enemy controller. So basically it's saying, hey, if there's a path, right? If the enemy controller has a path that it wants to follow, and if mover is null, so if like we didn't go and create this already in our patrol path, if this hasn't been created, which we need it, I guess there's some logic in there that we need, go ahead and create it. So path.create mover, and we're going to grab the max speed from the enemy controller. So animation controller has the max speed in there, and just drop it down by a half. Whatever, they're just doing their testing and they figure that's fine. Now go into, this is going back into animation controller, and then move it. We'll take a quick look at the animation controller. So there's some move method going on in there. And we're going to grab the X value. Oh, it's going to say, so vector 2, we're grabbing the X value. And then we're going to clamp. So clamp from the math library. We're going to pass in a value. So we're going to pass in our X position of the mover and subtract it from the current transform position of the enemy, and whatever that difference is, if it's less than -1, if it's too low, just return -1. If it's greater than 1, if it's too high, just return 1. If there's anything in between, just return that. All right, so if that's running in the update, I'm just gonna check. Yeah, so patrol path just has this mover. And okay, here's the position of the mover. So inverse lerp. I'll explain a little bit what a lerp is. A to B value. The value between 0 and 1 representing where the value falls between. Okay. So we're going to go from 0 to the amount of duration. How long do we have in our journey? And we're going to ping pong back and forth. That's why he moves back and forth. It's a little, I'm going to say it's a little unconventional for game programming because he's like making it a little hard. Normally you just, we do use lerps, and you move back and forth like this over a certain amount of time. And a lerp is so he's already using like an inverse lerp. He's kind of doing a little bit more complicated stuff than I wanted to show you. But a lerping is used a lot, and it's just called a linear interpolation. It's basically how to create animation from your code. And so it's like really convenient if you have like a dynamic level and your movement is kind of dynamic, and you can't like set it just with like an animation controller. You kind of have to like run it dynamically with your code. So a lerping is we have a start position and an end position, and over a set amount of time you have to move. I'm trying to find. I guess the straight line one might be. Yeah, okay. So when you call the lerp function here, like using vector3.lerp, so there's a vector2.lerp, a vector3.lerp, because there's 2D games and 3D games. But basically, it's like saying you have a start position, an end position, and the amount of your journey that's been completed. So when in a vector2 game, like here, you can see the start position is this much over in X and this much over in Y. And here we're starting here for our enemy. And then here's his finished position. We're going to move even more in X. We're going to move even more in Y, right? And so we're always going to start here and end here. And then it's like, well, how much time? So what we do is say, okay, that's what that whole duration was here. So it's like saying, okay, here's the length of the journey in vector 2, but let's just grab the magnitude of it. So it just returns like the big amount of number, like how many miles is this person going to walk? And then divide it by that person's speed, and you'll get like the amount of time of the journey. And so the duration is important because if it's 1 second or 10 seconds or whatever, ultimately you have to say, well, how much time has gone by, and are we at 0% of our journey, or 10% of our journey, or 20% of our journey, or 100%? That's why we go from 0 to 1. So when we lerp and we pass in a start position and a finish position, and we do like some calculations and we figure out we're at 0, like the beginning of our journey, we'll be placing our character here. And the next time we do this, like in our update loop or whatever, we do our lerp, we pass in our start and our finish, and we do our calculations with like the current time and the duration of the journey. And then we figure out, oh, we're halfway through the journey. We're at 0.5. And then the lerp function will figure out, oh, okay, here's the position that you need to place the character. And then when we get to 1, we finish the journey, we put them there. So lerping is a really important concept. Unfortunately, this is a little bit of a more complicated introduction with this person, with this developer's code. But basically, while we're talking about this, the ping pong lets you have like an animation that kind of moves back and forth. You don't stop, right? So a lerping, you figure out the start and the end, and you figure out like how far along you are in your journey, and then you're done basically. But a ping pong function will let you bounce back and forth between that start and that end. So here we're coming from the math F library as well, and we have ping pong returns a value that will increment and decrement between the value 0 and length. So you pass in basically time, and then you pass in the length. So the current time that exists and the length of the animation that's been happening, and it'll kind of tell you where along your journey 0 to 1. So it's kind of like, you could think of it as again a lerping like 0 to 1, but it's kind of like considering that you're going to be ping ponging back and forth to like eternity basically. So as the number, the amount of time that this has been running, it's calculating, should I be moving this way or this way or this way or this way, just back and forth. And it'll give you a number between 0 and 1, and you just pass that into the lerp function, and you can get like a repeating lerp to like however long you need it. So basically what's happening is they're doing this ping pong here, right? And remember, this ping pong is going to go back and forth between 0 and 1, or 0 in the duration. And it's like saying, give me the current time that currently is happening in our game, and subtract the start time that this animation started. And that's how long we've been in our ping pong effect. And that'll calculate based on the length from 0 to 1, where should we be between 0 and duration, or 0 and 1, to get you this ping pong effect. But ultimately, this will return between 0 and duration. And we're going to do an inverse lerp, which inverse lerp and lerp, ultimately you're going to return how far you along your movement along this animation path. It's just a lerp takes in determines where a value lies between 2 points. Okay, so a lerp method is saying pass in your start, pass in your finish, which can be a float, a vector 2, a vector 3, depending on whatever you're doing. It can be colors too, but and pass in how far along you are in your journey, right? And it'll tell you, oh, here's your point. Here's your position on your journey. Now, inverse lerp does the opposite of that. It says, okay, pass in your start and your end. Start A and B are also known as the start and end. And pass in the value, where you are in your journey. So pass in your current position of your journey, and this will tell you basically how far you are in completing your journey. So it'll give you back this like 0.5, this one, like if I say this is my start, this is my finish, and this is where I currently am. An inverse lerp will say, oh, okay, you're at 0.5, you're halfway through your journey. So whatever, this p value is just saying, find me where I am in my journey from 0 to 1 in my lerp, if you take into a consideration that we're going to do a ping pong. And then it'll say, okay, here you are in your position 0 to 1. And then it returns and eventually does that lerp. So all that I had to talk through to get to the point of, here is the vector2.lerp. And the lerp linear interpolates between vectors A and B by t, the amount of progress. So here we're saying, okay, path.start position is where we're starting. Path.end position is where we're ending. And we're this far along our journey from 0 to 1. And this is what we're returning. So this tells you where you are in your lerp. And it returns the vector 2. It returns the position where you are in your journey. And it looks like since we are working in 3D space, we have to take that vector 2 and transform it. Oh, transform it from local. So this lerp is returning a vector 2. Okay, this transform point's overloaded. So I'm looking here and it says it's expecting to receive a vector 3, but it's overloaded, meaning you can also pass in a vector 2. In any case, you pass in a vector 2 or a vector 3. I'm guessing the vector 2, they just add a depth, like a 0 on the z. But transforms a position from local to world space. So local and world space has to do with this hierarchies of game objects. So if I quickly create, what's used for a lot is, if I just take one of these enemies, if I take this one and just duplicate it and just move it and parent it underneath this one, and notice it's like offset a little bit, right? So if I take the parent and I move it, the child comes along, it stays relative to it, it's in its local space. So if I go down a level and look at it, it's just like off. You just make it a nice one. It's 1 unit off to the right, and it stays that way wherever the parent is going. It's just being offset by 1. That's its local space, like +1 in the apps. But where it's super used, it's like when a bunch of stuff comes together. bunch of game objects, but you want them to be connected. Rotation, it's used a lot. Like notice how the parent is rotating about itself, but the child is rotating about the parent because it's a locally offset. So this is the idea of global and local. But anyway, it just seems like they whatever transform they ultimately were working in some type of local space and they had to pop back up to world space. But ultimately, this thing returns a vector 3 back after all that insanity. And if we go back to enemy controller, this thing, it figures out its position based on that ping ponging and lerping between that start and that end point. And it figures out where it's at. And then since this thing is updating, like we're ping ponging, it can be like off a step from our main transform because the transform hasn't been updated yet. We're like updating it to whatever this animated ping ponging effect is. And that's how it's updating the position of the enemy controller. So that's this patrol path. So that's where the start position is just like a unit to the left of it, or 1.3 to the left, and then he moves 4 units to the end, basically here and here. All right, I'm going to take a quick peek at the animation controller because I know that we were messing with. Oh, this is pretty interesting. It's taking care of itself, kind of similar to the player. So it's kind of managing. It's using like the same animation controller. Okay, cool. But it doesn't have as many animations as the player, but it is kind of pushing itself along. Kind of similar, like if it was receiving user input, it's just kind of like saying, "Hey, this is your speed," and it's moving the blob along and figuring out like, am I in a jump animation or should I be in a jump animation or like a run animation? Okay, let me just check my time real quick. So we got about 30 minutes. What I'll probably do is cover tokens and let me read up on the tile maps. I've just never used them before. I got to read up for them for Friday. And then the other thing is we have to figure out. It's not going to take me all of Friday to do the tile maps. So we're going to have to jump into the next project on Friday. So I'm kind of up in the air. I don't know if anyone wants to do a vote or if anyone's interested in what at the end of this class after I cover tokens and how the tokens are working. I would like to have you start loading up the next project because it's gonna take a while. So I kind of want you to do it in between the Tuesday to Friday. So some of the other micro games. That we're going to be looking at. So if this took me one section, I might get more than past these two. But anyway, my next two are the karting and the first person shooter. So one is more physics based and one is more like 3D math with gameplay, like shooting. So this is the karting game. And now we're going to spend the rest of the semester basically in 3D starting on Friday. So it's up to you if you. We're going to cover both, so it doesn't really matter. But I don't know if people want to vote if you're more interested in moving into karting or the first person shooter next. But if you have a preference, you could just put it in the chat, and I'll take a look at what everyone's preferring to move on to next while I cover tokens. All right, so if we zoom out, there's a lot of these shiny diamonds. There's a whole lot of them. And let's take a look what's going on here. So we have this tokens group. There's some sorting going on here. Sorting group. We're not really sure what they're sorting, what this being used for, because that's more of a UI thing when you're like doing a vertical or horizontal sort. But in either case, we see that I'm going to click on one of these tokens, and we see that we have a transform. We have this sprite render that we're used to, and this has a circle collider. Sure, why not? It's a little bit bigger around the graphic. They want to make it a little bit easier for you to grab the token. And then there's this token instance script. And I'm just going to hunt around and make sure that stuff. Okay, there's a token controller. Let me just quickly look at this. The game controller is so high level. It's like not even worth looking at. So we have this token controller. So this is kind of interesting in that he chose to manage the tokens as this type of collection, and it's interesting. So it's a little bit little over engineered, but I kind of like in this situation. I think it works well. So as far as like a learning experience, like the other parts of the game, like like the I wish to like you should have just done a lerp instead of like a ping pong to a reverse lerp, because it's kind of hard concept for people to first get exposed to. But in this case, this is interesting, and I do like kind of how he's managing the tokens. Although I'll see where I have to kind of glaze over a little bit. So we do have this token manager sitting up here, and then we have every token has a token instance. And I'm just seeing if the token instance goes out to the token controller. Yeah, it does. So I'm just seeing which one to talk about first. Internal. Hold on a second. Let's see. Okay, it's an access. Only other people of the same type can modify it. But I mean, everyone's type mono behavior. But anyway, token. Probably maybe just look at token controller first. I think it's going to be so. Order of execution is interesting. When you have a lot of game objects and they have a lot of scripts, a lot of component objects, and you the player clicks play, like what happens, so everything's got this like start and awake methods, and like which start is called first. So you have this kind of order of operations. So when you go to scene, you move down. So each game object moving down will get processed first. It'll go through all of its components and look at all, like, is there a start or awake or whatever. So if you ever like want to know what is being set up before something else and is it like ready, you can have this kind of like the situation where you're like reaching out to another component object and you're trying to mess around with it and access it before it's like set itself up. So just know, like, order of operations, like tokens can go up and like call stuff on token controller, because token controller will get like its start method called first, whereas the opposite is not true. Like when the token controller is going through its start method, it can't mess around with whatever you're calling in the start methods of the token instances because they haven't been run yet. So that's kind of why there's like a start and an awake. Like one is run after the other, like update and late update. But you do have to kind of consider these things. So the token controller. It looks like we have some type of frame rate, like how frame rate usually deals with animation, like how often are we going to update the sprite graphic to make it look like it's moving. This is nice because this allows me to talk about arrays. So let me see up here. Yeah, okay. So instances of tokens which are animated. If empty, okay, they're loaded at runtime. So if I open this up, the list is empty, right? And if I click play, so at runtime, at start, token controller is going to go out and build this list, this array of tokens. Now look, boom, boom, boom. Here's all of our tokens, all of our token instance component objects and all these tokens. So this list, 100, is built from all these at runtime at start. So when you see these square brackets, you can we can start to talk about arrays or lists, or like linear collections, just like a sequence of elements that we can move through easily. So we're just looking at kind of like one object, like one int, or like one component object. But when we have many of them, and then like you have to create a variable for each one of them, it gets really, and you have to like name them, it gets really like hard to deal with. So arrays are a nice situation where you can like make, hey, I'm going to have an array of token instances scripts, and I can keep putting them in there, and you can reference them with indices really quick. You can like move through an array and do stuff to a whole bunch of token instances. So that's what this this array is. So it's like saying create an array of type token instances. So in this language anyway, you have to say I'm going to create a collection, an array, and it's going to be of this type of object. And so here, let's see what's happening in awake. So if tokens.length is empty, so if you didn't manually build this, you could just manually keep adding and dragging stuff onto it, and your tokens controller will only use those tokens. But why do it manually when you can have the computer do your work for you? So if this is empty, if the length of this array is 0, meaning there's no elements in it, then we're going to run this method, find all tokens. So go to the Unity Engine namespace, which you could have just done. No, there's using Unity Engine up here, so this is stupid. You could just done an object like this. So go to unityengine.object. So object is like this superclass, like everything is inheriting from this object class. And so this class has a nice little method, find objects of type. And it's like saying, okay, which type are you looking at? So notice it's not game object, it's object. So we're not interested in finding game objects here. There's other things that we might be interested in, other object types. In this case, we're interested in finding token instances. So if I click on one of these token here, and this game object has a token instance component object. So I'm interested in finding all of these type of component objects in my game. There's a lot. I don't want to go through here and like manually drag them all. Do it for me. So find objects of type, right? It's going to return an array of objects. Notice, look at the return type, token instance with those square brackets. Square brackets mean arrays. And then here is the angled bracket. So this is interesting when you have a method and you have like smooth brackets, like you're passing something in to it. Then it's like, well, what are you passing in? What should I be running? And you can pass in different objects, and then like in that method you have to do a check, like what are you checking. But the problem with that is there can be custom objects that like developers create that a Unity developer is not aware of. This is a custom object, so like this platformer game dev made it. So these are what's known as generics, these angled brackets, and you were kind of getting exposed to them in section 1, and I was kind of glazing over it. But this is really useful when you're saying, okay, I have this method and it's going to receive something, some type of object, but I don't know what that object is. And these are what are called generics. And like when you're not going to see what this method looks like, but it like when it references this generic and all of its kind of method body, it uses this these like angle brackets. It's like insert here. It's like a placeholder. It's like whatever the developer writes. In this situation, I said, hey, I only want token instance. So this thing will only go out and find token instance. So anyway, it's a nice way to be like, okay, there can be like an infinite number of object types because devs can make whatever they want. So let's just make this idea of generic so that we don't have to write methods specific to receiving certain objects. You then notice it's still a method call. Here's the smooth brackets. So this is just the generic part of it, the angle brackets, and then here's the method call, smooth brackets. But anyway, this goes out into your scene and returns back a list, an array of all these references to all these component objects of type token instance. Now we have it. Boom. We have it here. We can reference it. So after that's done, now we're going to loop through it. So this is a for loop. So for loops are super useful. It says for, and then we're going to evaluate here, and then we're going to do some work. So for loop structure is very standardized, I should say. So this part is first. This is our initialization. So it's a statement. Notice there's a semicolon. It's like a complete line of command, semicolon. Here's like another line of command, semicolon. And then here's our last line of command. So these semicolons are being used to like separate these statements. So it's a little interesting. The for loop has been around forever, so it has this like convention to it that's a little odd, but you get used to it as a programmer. So we're going to create a variable called I, set it equal to 0. Let me just write this as an int. Might be a little bit easier. We're going to create an integer called I, set it equal to 0. This is our initialization. Then we do our check, our logic check. Hey, do we pass this logic check? If so, do the body, do the increment, and do the logic check again. So as we move into the logic check, is I less than tokens.length? So in this case, tokens.length was 0, but then we went out and we ran this and it ended up being 100. So is I less than 100? Yes. So we run this, and then we increment, and this becomes 1, and we say is 1 less than 100? Yes. Run this, becomes 2. Is 2 less than 100? Yes, and so on. Up until 99 less than 100, yes, and then we run the increment statement. Plus plus is shorthand for saying +1, and then this becomes 100 less than 100, false, and we leave. So this is run 100 times. Now, arrays and collections, we start counting from 0. So an array of size 100 to access the elements actually is from 0 to 99 because we start counting at 0. So this is an array of integers. This before and the position. So it looks like we have position 0, 1, 2, 3, 4, 5, a size of a length of 6 elements, and the value of the element is 2, 4, 10, 5, 15, 3. These can be changed. These are just this is an integer object, and just at this moment in time, the values happen to be this, right? And so these are usually like object references. They're pointing to stuff, or if they're integers or floats, they're listed as numbers. But what's important is that these are the positions. So if you say, hey, give me my array at position 2, and it says, okay, what do I have in here? It's a 10. It says, okay, give me my array at position 4. What do I have in here? Oh, well, we have a 15. So these are the values at this position. Here are the positions. So it's like, how do you know what do you want to access? You have to say what position you want to get into. So here it's like saying, hey, go to position 0 of our list and access the element. The element is not an integer here. It is a script. It is, it is a component object. So it's this component object is 0. This component object is 1. And this one is 2. And this one is 3, and so on. So it's like saying, get me my element 0 and go into it and get this and set its property to this and set this property to this. So it's like saying, go into each token instance, and we have a property token index, and we have a property token controller. So these two here, which this one is defaulting to this one is set to -1, and this is set to null because it's not set to anything, right off the bat. And then this thing goes in and says, hey, for everything that's in my array, let's go in and access them, and then set token index to whatever this number is, right? So to be 0, 1, 2, 3, 4, 5. -1 is actually like an invalid number. When you reference an array, you'll get like an error. That's why it's set to -1 by default. And then set the controller property, which is this one here. Set this, which is now null. Set it to this instance of this token controller, which is this component object right here. And so those two are being set right off the bat. Boom, on awake. Go through find all the tokens for each one. Go through each element in my array and set this property to a number and set this property as a reference to this script token controller. Okay, that's hefty stuff. Let me know if you need me to go over any of this. All right, and then on update, this is how it's going to be animating it and seeing if they're collected or not. But before I go through that, on awake, it went through all the tokens and it set some properties for them, right? These token instances. So let's see what's happening over here in token instance. On awake, later on in the awake part, because these are component objects that are sitting on game objects there later on. We're going to get the sprite render. So if I go on a token, it's like saying, hey, token instance, go up, and I want to know about the sprite render that's sitting on my game object. If there's random animation start time, let's see if there is. Yeah, it is. Random animation start time is ticked on. Then let's see, our starting frame of our animation will be pick a random range. So go into the random class from the engine, use the range method, which receives a min and a max. It gives you a random number in between, and go from 0 to the length of our array. Or I'm sorry, sprites.length. I was thinking of the other array. So sprites. This is an array of our sprites. So we're going to move through. So this collectible spin right here. So this token spin is a PNG. It has these sprites in it. And as I move through, I'm pressing the down arrow. It looks like this. The animation looks like this. So it's like saying, give me this whole list of all these sprites that I want to move through and animate. Give me a random one to start with out of the whole collection. So that all the, I bet you if I click play, my character will jump over. But all these will start on like a different animation frame, so they're not all moving together, which makes them look kind of, I guess, boring. But if I click play, I know I only have a few minutes left, so I gotta finish this up. This one's by itself, so it doesn't really help. But if I zoom in, that's why, notice how they're all like sparkling at different times, and it gives you kind of the illusion of like, wow, there's like, they're all unique and random, and they're so alive because they're sparkling differently. And actually, it's just their animations being offset at the beginning, so they're starting at different parts of this animation cycle, sprite sequence. Anyway, that's our starting frame, and then sprites equals idle, and yeah, so whatever our idle animation is, which is up here. So our idle animation, they went and said this is how they created an array, but manually they kept clicking the plus sign and dragging over. So they just drag over 1, 2, 3, 4, 5, 6, 7, 8, 10. So that's a lot of work. So that's the reason why you would want to make this into a prefab. It looks like they just made this a game object and kept copying it after they set it up correctly. Like, you don't want to like drag and drop 12 things times 100. You just want to do it once and then duplicate all your effort instantly. Cool. So there's just like on trigger enter, if we figure out we're hitting the players hit us, then we run this. So before we look at what's happening here, we can now say, okay, the token controller, every update frame, it's actually in charge of animating all of the tokens. And it's like he built his own little animator. And it allows it's interesting because it first off, it allows you to see, like, you don't have to use the animators. You can animate your stuff with your own code. And behind the scenes, the animators are just, code, either C# or C++, and it's doing some similar stuff. So in this case, I do kind of like it as a teaching lesson that that this developer did go a little behind the scenes a little bit more than he should have. And it's light enough. It allows me to talk about arrays. So if the current time minus next frame time, so next frame time is by default set to 0. And when we start the game, this is 0. So 0 minus 0 right off the bat. Is 0 greater than 1 over the frame rate? And so the frame rate was 12. So we want to do 12 animation cycles a second. So 1 divided by 12 is 0.083 seconds. So we're saying, is 0 greater than 0.083? False. So we don't do anything. But the next update frame, this grows a little bit. And this grows because, more time has passed in our app. And eventually this number will get to something like 0.09 or 0.1. And right now this is set to 0. So it's like 0.1 minus 0. Will 0.1 be greater than 0.083? And that's yes, it is. Okay, now it's time to switch our sprite image on our sprite render, act like an animator, because like a 1/12 of a second has gone by or more than that, and we need to swap out our image to make it look like it's animating. So now we go into a for loop, and we do our initialization. So we set our variable I, to which lets us move through our array of sprites, and is I less than tokens.length. Oh, sorry, this isn't the sprites array. This is the token array. So we have about 100 tokens. So 0 less than 100, yes. So then we grab token's 0, we grab the first token instance, set it to a variable. If it's null, it means it's been disabled, that the user already grabbed it and turned it off, and so we don't have to animate it anymore. But if it's not null, then we go into the render property of that token instance and grab the sprite, which is like saying, go to here and grab this thing here, and we're going to swap it out. We're going to change a different sprite to render, and then go into its sprites array. So remember, we set up the sprites array here in the token instance, and we filled it up with sprites that we're going to move through. And and then we're going to say, okay, if the token's been collected, that means if the player touched it, some stuff's going to happen. Else, I'm not going to do this right now because we didn't get to the player situation, but this is what's going to happen. Because the token hasn't been touched yet, it's just going to animate. So take the frame that we're going to, like, whatever we were on, let's take it, add 1 to it. So let's like move it up 1. So here. So let's just say, remember we randomly picked one to start with. Let's just say we start on this one. And then we say, okay, go to this one, +1. And +1 and +1 and +1. And keep moving every 1/12 of a second. But what happens when we get to the end here? How do we like cycle back on this array of sprites? Well, that's what this modulus is doing. So as we move through here, we mod by the length. So a mod is kind of an arithmetic operation. It's just something you don't see written like this. So it's like how to get the remainder when you divide stuff. So, for example, if you were to, here's an easy one. I got like 2 minutes. I gotta wrap this up. Maybe this one might be good enough. So we have divide and modulus. Divide you've used a lot. So 13 divided by 6 equals 2. So when you do division in the computer, you do integer division or float division. But if you did integer division, you don't return like 13 divided by 6 is going to be like 2 dot something. So it's like saying 12 divided by 6 with like a little bit left over, right? So 6 goes into 13 twice, and you get 12. But there is a remainder. So when you do 13 mod 6, you get a remainder of 1. Because you get 6 times 2 equals 12, and then plus 1, you get 1 left over. So if you see it here, you have the divisor and the dividend. So 3 are like 17 divided by 3. How many times does 3 go into 17? And 3 can go into 17 5 times. 3 times 5 is 15. But it can't go in 6 times because that would make 18 above 17. So when you take 17 divided by 3, you get 5 with a remainder of 2. So if you do like the division in computer science, you get the 5. Like integer division, you get the 5. But if you did a modulus operator, you get the remainder, or 2, of our operation. So this idea of the quotient in the remainder. And so in computer science, divide and modulus. Now, why is there this modulus operator? Because the remainder actually is super useful. And I'm gonna stop here. in just a second. But it's like saying whatever this number is, mod it by the total length. So, and then we're gonna set token.frame to that. So what that means is, remember we count from 0 to 12. So this is an array of 13. We count from 0 to 12, right? So if we were here and we add 1 and we get 6, and we go 6 mod 13, and what's the remainder here? We're going to get 6 back. And then 7 mod 13, we're going to get 7 back. 8 mod, 9 mod, 10 mod. We're still going to get like that number back. But if we go, and then if we do 12 mod 13, we'll get our 12 back because we haven't like gone past 13. We still have like this remainder. Now, if we go one more, we get 13 mod 13, we'll get 0 back because 13 divides into 13 evenly, and we get a remainder of 0. So anyway, it's just a little math trick to say, hey, whenever we keep incrementing and we're moving past here, and we're about to go past the size of the array, it like sets it back to 0 because 13 mod 13 is going to equal 0. There's no remainder when you divide 13 by 13. So you could also do an if check. You could just say, hey, token frame plus 1 is the new token.frame, and say if token frame is greater than or equal to length, then you just say equal to 0. So you could do a logic check here, or you could just do the math. All right, but this is how it's animating the token. It keeps like every 0.83 seconds or 12th of a second, you're just changing the sprite animation. And I'm going to stop here because we're out of class, but I didn't cover like when the player touches the token. So I'll cover the player touching the token, and I'll cover let me just make a little note, and tile map. All right, so I'll cover player collision with token and tile map. Oh, last, right, everyone did a vote, and let me see what's going on here. I'm going to stop the, actually, no, I'm going to leave the video going because I need to load this up. Karting, FPS. All right, I'll do FPS and karting. So for Friday, I have some less to cover with first person with platformer, but we'll do first person controller, and then we'll do karting. And if those of you have to leave, head out, I'm going to just cover loading up the first person game. You can just watch it in the videos. You can just do this like in between classes because it's going to take some time. So I'm going to close out Unity Editor. I'm going to create a new project. I'm going to create an empty 3D scene. We did 2D last time. Do 3D. And I probably have this. I just want to make sure I'm not do a little bit of a longer name so I know that, because I've probably done this in previous class. First person shooter, micro game. How it already exists. Spring 2024. Okay. Unity. Select that. Create the project. Well, I'm waiting for this to load up. If anyone's got any questions, let me know.
What can I do if I'm interested in seeing what I got wrong on the quiz?
Just email me, and I can send you the questions. I can just copy and paste the questions they got wrong.
Thank you.
Yep. All right, should be done almost soon. I should have this up here and also say that we're doing first person shooter first. Yeah, have a good one. I just put the if you guys want to get people loading up first person shooter, it's gonna take a while. Anyway, project is up, and so then I can go to the asset store and say open in Unity. And it looks like I have to download it. It's probably out of date. And next step after this is just importing it. It's just going to take a long time. Okay, and then it's been downloaded. You just click import. Import, it's going to override project settings. Okay. Yep. Sure if you need to upgrade any parts of the Unity package, any packages that there are. This is why stuff takes a long time. I just want you guys to do it for Friday. All right, I think it's almost done. All right, and this is the import. The GUI say, what do you want to import? And I'm just, everything is new, empty project, just bring it all in. This is saying, okay, wants to override these project settings. That's great, do it. And that's it. And that's going to take a really long time. Yeah, exactly. There was some, like, a lot of dependency packages that needed updating. And then you saw, like, it was, it's a 3D game with really heavy assets, and so it just took a long time to like build the asset folder from the library. And yeah, we'll still be doing carding. Yep. Oh yeah, we still have a lot. I'm not going through the rest of the semester with this. And then it took a while even to bring up that import wizard to show you what was coming in, and this is where I'm going to end it because this is probably going to take like 30 minutes or something. But you need to do this outside class time because it just takes too long. So I'll get this video up, and I got to go get up to speed with the tile manager system. And then, yeah, we'll be doing the driving game, the karting game. It's just we'll do first person shooter, then karting. And I feel like there's still going to be a few weeks at the end. I'm going to see what else there is. Or I'll just do what do people want to mod, and we'll jump into different gaming projects and keep learning more stuff. All right, with this, I'm going to stop